Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to have an introduction to power series. And power series are basically like functions that can be written as a series of polynomials. So before we delve into that, I wanted probably I made a video similar to this one before, but this one is specifically to address that topic of power series. If you remember, we expanded, for example, sine x, cosine x, e to the x, natural log of 1 minus x, and stuff like that, or 1 plus x, I can't remember. But what we are going to look into here is some functions. Let's start with easy ones. So for example, if we say 1 over 1 minus x, do you know how to expand that? Well, here we assume that the absolute value of x is less than 1, okay? So, yes, if I give you the series itself, it's a geometric series, and its sum is 1 over 1 minus x. However, when I was much younger than now, of course, uh, I mentioned in another video when we were discussing the quadratic equations and solving or factoring, say, a quadratic equation. I told you that when I was a kid, because we didn't have calculators and I want to quickly check my answer, I used to consider x to be 10. Why? Because 10 was easy. If I have x squared, it's 100. I don't need a calculator. 10 to the fourth is 10,000. Why would I pick any other number? And it was so easy to check to see if the equation is correct or not. Again, if you are interested in that, you can go to the playlist of mathematics made easy, and you will find it there. But when it was something like that, I would assume x is 0.1. 0.1. Notice that if I say x is 0.1, then that would become 1 over 1 minus 0.1, which is 1 over 0.9. You know how to divide 1 by 9, right? In fact, I was just discussing that in a funny video a short while ago that you will see posted also in Math Made Easy playlist. Now, I know that this is 0.1111 till infinity. So that was, I'm sorry, 1 point, because you divide, I was talking about 1 over 9, but this is basically 10 over 9. So you get 1.1111. But if you know x is 0.1, it's so easy to know that this is 1, but then the 0.1 is x, the 0.01 is x squared, and then x cubed till infinity. In fact, you know that if x is here the multiplier of that geometric series, right? You know that the summation of that is 1 over 1 minus the multiplier. So if x, say, is 1/2, you say 1 plus 1/2 plus a quarter plus 1/8 plus 1/16, and so on and so forth, you will get 2, which is 1 over 1 minus 1/2, or 1 over 1/2, or 2. If it's 1/3, you get 1 over 1 minus 1/3, which is 1 over 2/3, or 3/2, which is 1.5, and so on and so forth. So now I know I can remember that even when I'm too old like I am now. I never forget it because it was easy. It turns out that if you divide 1 by 1 plus x instead of minus x, you will get the 1, and then the signs alternate, negative, positive, and so on and so forth. minus x plus x squared. So when the power is even, you get positive term. When the power is odd, you get negative term, and so on and so forth. So these were so easy. In fact, if I already know that, I can substitute negative x. So I can rewrite this as 1 over 1 minus negative x. And now it looks exactly like that. So I should get 1 plus negative x plus negative x quantity square plus negative x cubed plus, so that would simplify. Positive times negative is negative x. Negative x squared is positive x squared. Negative cube is negative and x cubed plus, and so on and so forth. In fact, even if it wasn't 1 in the denominator, let's pick something else. Let's say 1 over some other number. It doesn't matter. Let's pick a number, 4 minus x. Okay? I can divide top and bottom by 4 just to make that 1. So it would be a quarter divided by 1 minus x over 4. So that would be 1/4, oops, 1/4 times this equation, but instead of x, I'm going to use x over 4. So it would be 1 plus x over 4 plus x over 4 squared plus till infinity. So it becomes a quarter plus a quarter times x over 4 plus a quarter times x over 4 squared, and so on and so forth. Okay, so these are very easy, easy stuff to remember. And then, as I said, if it's not x, or if it's, say, 2x instead of x, or there's a number here that is subtracted or added, you can easily manipulate it and make it in one of these two forms. That's why these are very powerful series that we will see and we will be using next session in the power series. I think I had something in mind to show you. Yeah, again, let's say this was 1 over 1 plus x squared instead of x. Well, what you have to do is that instead of x, you would write x squared. Notice 1, and then you keep alternating the signs. So minus x squared plus x to the 4th minus x to the 6th plus x to the 8th, and so on and so forth till infinity. And again, this works. Suppose when I say, for example, x is 0.1, right? This would be 1 over 1.01, or it's 100 over 101. And you can again use your calculator to find it, uh, and you know how to do that. I can show you the pattern and then you will see why. So if I divide 100, oops, my batteries are dying. 100 over 101, you see 0.99009900, and so on and so forth. Maybe we can discuss that, why you get these much easier. You say, but how do I get nines into ones? Very simple. Notice that the 0.99 can be written as 1 minus 0.01, which is 0.1 square. Notice this is, I'm sorry, I wanted to say, yeah, 1 minus uh, plus, it should be 0.01, right? No, 1 minus, it's already square, so it's 0.1. Yeah, this is zero point 0.1 square. So it's zero point 0.1 square plus zero point 0.1 to the fourth minus zero point 0.1 to the sixth. So if you want to write it, it's 1 minus 0.01, which would yield 0.99. And then you add 0.0001. And then you subtract 1 to the 6, which is 0.000001. So, and you keep doing that. You see here you get 99, and then you carry over 1, so you get 0099. And sure enough, if you keep doing, you always add 1/100th, and then you subtract 99% of that. So it brings it back to, or yeah, it brings it back to 0.00990099. And of course, if that was a minus, I would add point. So if that 1 over 1 minus x squared, it would be 1 plus x squared plus x to the 4 plus x to the 6. So this is just a brief introduction to what we are going to do next time. So next time we are going to look at power series that look something like that, or maybe a little more complicated. And then we'll see whether when these series will converge, okay? And when they will diverge. So what is the interval of convergence? It's between two values. And we are going to use more vocab words for that. And it should be an easy session, but it's really nice to work with the numbers and the symbols in a easy way. Okay, so next time I hope you would like it. It would be I think interesting session. Thanks for your time, and I wish to see you soon. And again, if you have any comments or if you saw something I did wrong, don't hesitate to drop a line in the comments section, and I will get back to you as soon as I can. Thank you very much for watching, and hope to see you soon. Bye.